Okay, I'm going to get started. Technically, we're a minute early, but we have I will admit, surprisingly full room. I'm actually quite astounded to have this many people for the last slot of the event. So, 2 questions. 1, has everyone had a good show? Been worthwhile? 2, how many people have any mental capacity left whatsoever? Okay, good. When I get to the end of these shows, I'm just kind of sitting there going, So I'll try and keep it entertaining for you. I am warning you ahead of time. This is a session that I normally do in 75 minutes. They've asked me to do it in 60. I haven't actually removed any content. So A, I'm going to try and go fast, but B, it's entirely possible that I'm going to get towards the end and just be going like, okay, let's skip that slide. That's not critical. Let's move along. So let's get going. I'm Ben Armstrong, Program Manager on Hyper-V. And today, last session, I'm going to be talking about what we've done with live migration and storage migration in Windows Server 2012 and Hyper-V. Though, truth be told, this title is a title that was invented by the marketing people. I'm not a big fan of this title. It's got too many words in it. What this session is really about is how you can move VMs around and what you can do in Server 2012 that you couldn't do before. So, one of the things you may have heard in passing that Server 2012 is something about private cloud. You may have heard that a couple of times. Reality is, to do private cloud, you need to be able to move your workload around in response to what's happening. So, mobility of virtualization is foundational to building a private cloud. I do have people on my team who tease me whenever I talk about the foundations of a cloud, though. So, anyway, but I promise that's the last time I'm going to use marketing speak. Now I'm going to talk about the technology, what we've done. So what we did going into Windows Server 2012 planning and development was we said, okay, we've got live migration inside a cluster with Windows Server 2008 R2, and people really like it. But there are still many cases where getting a VM from here to there is far harder than it needs to be. So we spent a lot of time looking at what are all the different scenarios where in Server 2008 R2 it just wasn't possible to get a VM from here to there, and we tried to fix them. So the first thing we did was live migration without infrastructure. This was one of our big investments. No clustering, no shared storage, being able to live migrate a running virtual machine between 2 computers. Now, my good friend Jeff Woolsey loves to get up on stage and say, you can live migrate with just a cable, and he holds a network cable up in his hands. And I like to say, technically, that's too much and not enough. It's too much because, yeah, I've done a shared nothing live migration over wireless. That works. I actually have done it between a laptop and one of the Samsung Series 7 slates. That worked fine. However, it's also too little because we do require that you have a domain in order to do shared nothing live migration. So you do need to have a domain controller somewhere. Now, I'm about to do a step through of the architecture. But before I do that, I want to give you a little insight into the bitter, twisted person that I am. So I work at Microsoft, and I'm a program manager. You've probably heard that title a number of times. We're often the people who come out to do these presentations. And program managers, we have a very vaguely defined job. On the development team, we like to joke that developers write code, testers test code, and program managers do the other stuff. But what we do specifically is we spend a lot of time talking to people who actually use our software, trying to figure out what we need to do next, and then help run the program. Now, it is a secret joy as a program manager to make your developers suffer. But there's a challenge, because if they know that you're making them suffer, then they'll get angry at you and so on. So you have to play this careful game. And what I love to do is I love to come up with simple statements from a user. Like you could imagine a user saying this. Simple statements from a user which are impossible to argue against but have huge ramifications on the design. So when we started working on live migration in Windows Server 2008 R2, I came up with a simple statement. And the simple statement was, when I try to live migrate a virtual machine, no matter what happens, no matter what goes wrong, at the end of the day, that virtual machine must be running somewhere. Seem reasonable? You know, you either expect it's going to succeed and the VM will be over there, or it's going to fail and the VM will still be where it was. You know, there shouldn't be a scenario where, like, oh, we got it wrong, VM's gone. Have a nice day. That's not acceptable. So that's something that the development team actually really took to heart. And that made the job of building live migration without shared infrastructure all the more challenging. Because even with 2 standalone boxes just using local storage, we still wanted to be able to provide the guarantee that, hey, if anything goes wrong at any point in time, we can safely fall back, be running where we were, and you haven't had any downtime. So here's what we did. We took live migration as it existed. We have 2 servers, Hyper-V servers. We have a virtual machine with its virtual hard disks. And we'll point out shared nothing live migration supported with virtual hard disks and synthetic fiber channel, not supported with pass-through disks. But we have a virtual machine and its virtual hard disks. And we go in and we say, hey, I want to live migrate it from here to there. And the first little bit of this is very similar to traditional live migration. We connect, we do a negotiation, we make sure everything's okay, we open up a TCP connection for sending live migration traffic across. But now things get a bit different. Because what we actually do is we do a modified version of storage migration. And I'll talk about the storage migration architecture later in this presentation. And where this version is modified is we start sending the storage data across while the virtual machine still continues to run on the source server. And we actually get to the stage where we have complete copies of the virtual hard drives on both sides, and we're sending new incoming writes to both sides. So we effectively have created a storage mirror. And this is key to being able to provide that guarantee that no matter what goes wrong, the VM's going to be running somewhere. So once we've got the storage mirror in place, we've effectively created our own version of shared storage. And now we're able to go ahead and do a live migration just like we would inside of a cluster. We go ahead, we do the iterating over the memory pages, we transfer the memory pages across. Once we have the vast majority of the data across, we flip the virtual machine over. We have a very small downtime. You know, our goal is to be under the TCP/IP timeout window of 5 seconds. Usually we're in the 0.5 to 2 second range. We flip over and we wait to see, does the virtual machine start successfully on the destination? And we actually keep the virtual machine paused on the source until we get the confirmation. So we can fail even at this late stage in the migration. If something goes wrong here, we're able to successfully snap back to you're running on the source and everything's fine. But if it succeeds to power on, we then break the mirror, and the final step is to clean up the virtual hard drives on the source side. So I'm going to show you a video. Unfortunately, I can't do live demos at the moment. I do have a recorded video. This is actually more of a live migration speed run. So I'm going to have to talk over it. I did these as quickly as I could so we could try and keep in the time. So I have 2 servers here. Benam Zeta and Benam Epsilon. I call them that because I studied math in university, and as a result, when I'm looking for names, I go for the Greek alphabet. These servers actually have local disks. I've got them set up with the J and the K drive as where I store virtual machines. I just do that for convenience. So I'm going to do a shared nothing live migration of file server 1. To do this, I'm going to open the settings first and show you that it is on a local disk. I forgot this. So just show you it is local. There's no shared storage here. And I'm going to start a workload so that we can see that it is shared. And I actually have two workloads running here. I have ping and I have a file copy. And I'll explain to you why we do those two workloads in a little bit when the live migration is in process. But with both of those in place, I'm going to select file server 1 and I'm going to choose to move it. This is a wizard that we use for all move operations. I'm going to say move the virtual machine, the server I want to move to. I'm going to choose the easy option, which is just put all the bits in a single folder. And now, we've started the live migration. Now this is, by the way, one of my little pet peeves. I love developers. They're great people. The one thing that they cannot do well, they cannot do to save themselves, is make progress bars that actually progress evenly. So you're going to see a lot of wacky progress bars today. I can tell you this progress bar, when it's 34% complete, we're actually 98% complete. We'll get to about 34%, then we'll jump to 48%, and they'll be done. But right now, the virtual machine is still running on the source, and we're copying the virtual hard drives across. Now, I mentioned our goal is to have the blackout window be under the TCP/IP timeout. And that's why I have these two workloads. The one on the left is a file copy using TCP/IP. It will not be interrupted by the live migration. The one on the right is a ping, which actually uses ICMP. And ICMP is designed to detect short outages. So you will actually see one or two pings get dropped because of the switchover while the file copy continues. So a little bit while we're waiting for the progress bar, I'll just explain. The development team decided that they would use a unified progress bar model for all move operations. And they made some interesting choices in that. One, they decided that the first 50% would be the storage migration and the second 50% would be the live migration. So even though in most cases the storage migration is the far longer thing. Two, they use the same infrastructure even if we're doing standard live migration without moving the storage. So you can see we're just flipping over into the memory part now. But you'll see later when I do live migrations without the storage, it jumps straight to 50%. But there we have one dropped ping, file copy still going, virtual machine moved over to the other side, all without any shared infrastructure in place. So it really is very simple to do, and it's there right out of the box. And I've just showed the UI. It's also quite easy to do with PowerShell. So here's the PowerShell command to do exactly what we just showed. Move VM, name of the VM, name of the server, include storage, destination storage path, and where I want to store the virtual machine on the other side. So the next thing we did, so okay, we've got live migration standalone, was live migration with SMB. And we actually had people saying to us, you know, hey, I want to use SMB in my environment. Assuming you do that, don't have live migration be tied to cluster. For my environment, I don't care about high availability, but I still want to be able to move virtual machines around very quickly. You know, shared nothing live migration is great, but it ain't quick because you're moving the whole VHD. So what we've done is we now allow you to do live migrations on SMB where we just move the running virtual machine. We don't move the storage. It stays where it is. There are a couple of things you should know about this. The first one, it requires SMB 3.0. Second one, and I do have to be really clear on this, otherwise the clustering guys get mad at me, does not give you high availability. I do want to be really clear about that. If you want high availability, continue to use clustering. It works great. You can do live migration with it. The third thing to know is that it is a pain to set up the SMB shares. This bums me out. We did try to look at ways to make this easier, and none of them made the cut for this release. The reason why it's a pain is we require you to set up the SMB share with permissions both for the users who are going to be initiating live migrations and for the machine accounts of the computers where the virtual machine might be migrating to. Now that sounds bad, but it actually gets even worse, unfortunately, because you have to do this on the SMB share permissions and the file permissions. So you have to set it here. You can see I've got epsilon and zeta and my user account on the share permissions, and I've done the same on the file permissions. But the really annoying thing is if you go through the UI and you're like, okay, I want to add my machine account, and you hit the add button here, you'll get this dialog, you'll type in your machine account, and it's going to sit there and go, I don't know what you're talking about. That's not an account. Go away. And you'll go, I'm sure I typed this right, and you'll check, and This dialog does not accept computer accounts by default. If you have a look, you'll see users groups, built-in security principles, not computers. What you actually need to do is you need to click on object types and go and check computers, hit OK, then you can type in your computer name, then it works. This one trips me up all the time, and I know it's tripped up many other people. In fact, this is, for me, one of those occasions where I go, it's actually easier to do this from a command prompt than through the UI. And this is the command prompt to just go through, set up, and this couple of lines creates the folder, ACLs the folder, creates the share with the right permissions. That is something to be aware of. If you don't set the permissions right, live migration with SMB is going to fail when you try it. You will get a descriptive error message, of course, but it's better to get things right the first time. So with that in mind, I'm going to show you a very short demo of live migration on SMB. And the reason why it's short is, unlike the previous demo, we're not going to be moving any of the storage. It's like the live migration in a cluster, where we're just going to transfer the memory. You can see this VM is stored on an SMB share. I'm going to start the same sort of workload, and we're going to go through the same wizard. But this time, we're going to choose, there's an option where you can say, move just the virtual machine. And we're going to choose to move just the virtual machine without moving the virtual machine storage. I said that ahead of time because I fly past it in the UI. So we go in here, move the virtual machine, select the computer we want to move it to, and then we say move only the virtual machine. Don't move the storage. And you're going to see that we get the lovely progress dialog go straight to 50%. 50% done. Oh, wait a second, we've got a little bit to do here. But this will go across quite quickly. And I believe we'll see 2 dropped pings this time, if I remember this video. And we're back. The file copy is still going. The virtual machine is now running over the other side, only its virtual hard drives stayed in the same place. And this is the hardest PowerShell command you've ever seen. Do you want me to explain what it does? No, I think it's fairly obvious. So the final thing I want to talk about is live migration with clusters. We've been talking about, okay, we can now do live migration. Sure, nothing we can do live migration in SMB. But the fact of the matter is, we expect a lot of people are going to continue to deploy clusters and have their workload running in clusters the majority of the time. Now, high availability is important. So we had a look at, okay, live migration in cluster is great. What can we do to make it better? There are a number of things that we did. First, and this is true for all live migrations, we made them faster. Live migration is now able to fully saturate a 10 gigabit connection in order to get the virtual machine over there as quickly as possible. We've added support for concurrent live migration. So you can do multiple live migrations at the same time. We've done a lot of deeper integration into clustering around live migration. So a very simple example of this is in Server 2008 R2, if you had a node go down, and we started the virtual machines up over on another location, when that node came back up and clustering would try and do a failback, it would actually do a quick migration. It would take the VM down. So we've changed it so that clustering always uses live migration for all of its operations whenever possible. So now a failback is a live migration, just trying to keep the availability as high as possible. The other thing that we did a lot of work to enable is live migration between clusters. And you can do this just with the inbox tools. You can also do this using SCVMM. I was actually hoping to show the SCVMM experience today because it's quite simple. Unfortunately, my VPN connection isn't working and I don't have a video of that. So I'm going to be showing you the video of live migration between clusters, and I'm just going to be using a PowerShell script for this. So here I have a setup where I have two node clusters. BenArm Alpha and BenArm Beta in one cluster, BenArm Gamma and BenArm Delta in another cluster. And I have a virtual machine which is helpfully labeled the Windows Server to move. And this script is actually going to move this virtual machine between all 4 computers. It's going to start by doing a migration inside the Alpha Beta cluster. It'll move it from Alpha to Beta. Then, once it's done that, it's going to remove the virtual machine from that cluster, do a shared nothing live migration to Gamma on the Gamma Delta cluster. It'll join the virtual machine to the cluster, and it'll do a final live migration inside the cluster. A key thing to highlight here is, in the past, a lot of these operations, for instance, removing a virtual machine from a cluster, would have required you to turn the virtual machine off. We wanted to make sure that this was all possible while a virtual machine was running. And you might be wondering, hey, why does this matter? Why do I care about being able to live migrate between clusters? Well, what we've found talking to people is that it's actually fairly rare for people to just have one cluster. When we talk to people about how they're deploying in the real world, what we often hear is that people are actually deploying multiple clusters. And there are lots of different reasons. Some people do it for management reasons. Some people do it just as a way to isolate workloads. Some people do it because of business or external reasons. But it's very common for us to hear about people running multiple smaller clusters. And people in this situation go like, hey, the VM mobility is great, but it's a real pain if I have workload that I need to move between. You know, if I have one cluster that's now heavily loaded and one cluster that's lightly loaded. So this provides a way to do load balancing between those different environments. Now, another story I like to tell, and by the way, so right now we're doing the shared nothing live migration between the 2 clusters. And something that I do need to highlight here, very clear, for this one part, you aren't protected against hardware failure. So when you do, when their virtual machine is in the cluster, you have hardware failure, it's protected. But in order to migrate between clusters, you have to first remove from the source cluster, do the live migration, and join to the destination. Now, if you're unfortunate enough that in that window you have a hardware failure, then you are going to have that virtual machine go down with the server, unfortunately. So you can see here the scripts join the virtual machine to the second cluster, and we're about to do the live migration to the final computer. And one thing that I like to highlight with this demo also is I do demos all the time. And I have a little lab full of servers. But quite often I'll be doing one demo one week and a completely different demo the next week. Now with Server 2008 R2, if I had my lab set up as 2 4-node clusters and a bunch of things like that, and I found out that next week I needed to do a demo where I had some standalone computers, honestly, I would have just gone in and formatted those boxes and rebuilt, because trying to reconfigure them, just too much pain. These days, I can't remember the last time I turned a virtual machine off to reconfigure things. And it's not because I actually care about these virtual machines being up. They're just demo virtual machines. It's because with Server 2012, there's no advantage to turning them off. You know, if I need to turn some clusters into standalone machines, I can do that now without turning virtual machines off. I can move them around. I can rebalance. So now, there's some extra information that you need to know to ensure that live migration in your environment is secure and properly configured. The first thing to know, some basic security 101, we do not enable live migration by default. When you install Hyper-V, there's an option during installation to enable it. Either way, you can come into the Hyper-V settings later on and you can enable or disable live migration. The second thing to be aware of is we do allow you to configure which networks we use for live migration. So you can see that down the bottom here. I would strongly encourage you to configure those. The only time I want to see people saying, yeah, any network is if you're in an isolated test environment. Now, our guidance is that you should put live migration on a separated network, whether it's physically separated or separated with VLANs, where you can either guarantee physical security, which actually a lot of times you can. You know, if this is a data center and you're using VLANs, you can put your live migration on its own network and guarantee physical security. The alternate is to use some encryption method, for example, IPsec. And a story I have to tell here is whenever I say, like, you can use IPsec with live migration, I see a lot of people kind of roll their eyes and be like, yeah, right. I'm not going to do that. That's never going to work. So where I work in Redmond, and the domain that I work on is like it's the top secret Windows core domain, they actually enable IPsec by default. And there's no way for us to disable it. And the only way that we get to do testing with IPsec disabled is if we go to the effort of setting up our own domains for test purposes. And while I love them dearly, my testers do tend to be a bit lazy. So I can tell you that we actually do more testing of live migration with IPsec enabled than we do of it with IPsec disabled. That said, if you are considering using IPsec to protect live migration traffic, I would strongly encourage you to make sure that you have network adapters that have hardware offload for IPsec. It's important on gigabit. It is critical on 10 gig. In our testing, IPsec on 10 gig without hardware offload, please just don't do it. It's not worth it. But if you have the hardware offload, IPsec on 10 gigabit networks works perfectly. So the next thing to talk about, very unpleasant subject, but it's an important one, and that is managing security and authentication when it comes to live migration. So to get to understanding this problem, I need to explain some basics about Windows network security. So hopefully we're all familiar with the concept of I'm using Windows, I have a desktop, I connect to a server, I send my credentials. You know, I connect to the server as my user, and it does stuff. What you may not know is that by design, Windows does not let that server then turn around and connect to a third computer with your credentials. By design, that is blocked, and it's blocked for a very simple reason. There may be a bad guy on that server. And from your desktop, you have no idea whether that server is trustworthy or not. So by design, Windows stops that from happening. It's a protection that's built into the system. But how does this affect Hyper-V? Well, if you log into one box and you do a live migration to another box, that's great. And in fact, that's what I've been doing in all the demo videos that I show you. But if I sit at my desktop and connect the tools to a Hyper-V server and I say live migrate over there, then that's not going to work because Windows security stops my credentials from being sent on. So that's understandable. The next one isn't, though. And I am resigned. This is going to generate support calls. We're already putting together documentation for this. But this does not work. Because if I log into one server, open up our management tools, and I say, migrate VM over there, that works fine. Then, using the same management tool, if I say, OK, now bring the VM back, it fails. Because what Windows security sees is, hey, that remote server is trying to reuse your credentials. And this is really confusing. Little story, we actually detect this case, and we give very detailed error message for it. And we actually came up with a long, wordy, nice English legible error message. Unfortunately, you know how we have the little dialogues where you have the error message and you have the drop down for like show more information? Unfortunately, in the RC release of Windows Server, there was a bug, and those two texts were reversed. So when you hit this, you got this like incredibly technical gibberish. And only if you hit the more information would you see the clear English that tells you what to do. On the plus side, I can tell you, and I had to laugh because I ran into exactly this issue with System Center only a couple of weeks ago. I'm now very familiar with the technical gibberish, and it is some of the finest technical gibberish I've seen around. So let me share with you, if you're ever using Hyper-V and there's a message about the contents of the security package being empty, that's this. That's logical. But that's for some reason, that's the error message that gets produced by the lower layers. So this doesn't work. So what can you do about it? There are two options. The first option is you can tell Windows, hey, let Hyper-V reuse my credentials for this, please. This is OK. I trust Hyper-V. I trust this server. The second one is you can make it look like you're logged into that box. So your credentials aren't being sent on. So the first way is actually called enabling Kerberos constrained delegation in Active Directory. And this is actually not that hard to set up. This is grabbed from TechNet. This is the steps that you need to follow in order to enable it. But I've actually also screenshotted the process. So what you need to do is, unfortunately, you do need to be a domain administrator for this. That's the biggest drawback. But using the Active Directory tools, go to Active Directory Users and Computers. Find your computers that you want to enable this for. Open up the properties. In the properties, go to the Delegation tab. Say, trust this computer for delegation to specified services only. Use Kerberos only. And then you want to find the computer you want to go to, and also the services. And there are two services you need to enable. The first one is the Microsoft Virtual System Migration Service, and the second one is the CIFS, C-I-F-S service. You enable it for both of those, and then it just works. And two things I'd like to point out. One of the testers on my team, Taylor Brown, has done a fantastic series of blog posts talking about the different ways you can configure constrained delegation. He's also provided some sample scripts so that if you want to automate this as part of your deployment process, you can. The second thing is we do already have documentation up on TechNet that steps you through how to do this in great detail. So that's the link for that. So if you don't want to go down that path, the second option is make it look like you're logged into the machine that's starting the migration. So there are two ways to do this. The first way is PowerShell remoting with CRED SSP. This is actually very simple to do. This is what I do in my test environment. Very convenient. PowerShell remoting is enabled by default on Windows Server 2012, but PowerShell remoting with CRED SSP is not. To enable the CRED SSP aspect, there's a single command that you run on the server, this one, and there's a command that you run on the client. Now, one thing to highlight, the client command, you have to specify the servers that you let credentials be sent to. Fortunately, the delegate computer, the FQDN, accepts wildcards. So I'm lazy. When I'm doing this, I just go like, any machines in my domain. *domain. Let's make that work. Once you've done that, you have two ways that you can connect. You can use new PS session, which gives you the equivalent of a PowerShell prompt on that computer. Or you can use ICM, which is invoke command. And that's the one I use most often. And with ICM, you just like go, run this one command over there. So ICM, move VM back to me, please. And that works. The other option is just use remote desktop. And yeah, hopefully I don't need to go into great detail here. But yeah, if you use remote desktop, connect to the computer that's starting the migration. That'll work. The final thing that I'd like to highlight is how this affects SCVMM. So SCVMM has the same issue. The way you get around this in SCVMM is you either enable constrained delegation or you configure the run as accounts in SCVMM. If you use run as accounts, then everything works. If you don't want to use the run as accounts, then you need to configure constrained delegation. So now we've covered everything live migration. Let's talk about storage migration. Storage migration is basically we allow you to move any bit of a virtual machine while it continues to run. You can also move them while they're offline, by the way, but that's nowhere near as cool. But that does work. And I like to say there are two stories behind storage migration. There's the kind of the official story, or I like to call it the CEO-CIO story. And then there's the real-world story. And don't get me wrong, both of these are valid scenarios, but you'll see what I mean. So if I was talking to a CEO or CIO and they're like, hey, Ben, what's the deal with storage migration? Why do I care about this? I'd say, well, Mr. CEO, you have a lot of SANs in your environment, and you have virtual machines running on them, and one day you're going to decide to get a new SAN, and you're going to want to use that for your virtual machines, and you're going to want to re-provision your old SAN. Well, storage migration lets you do that without ever turning a virtual machine off. Hook up the new SAN, move the VMs, unhook the old SAN, life's good. So that's the official story. The unofficial story, which I believe is going to be far more common, is, now this may surprise you, but some people, surely no one in this room, some people don't read our documentation. Some people don't even follow best practices. In fact, some people, just throw the software on there, click next, 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 and get themselves into a whole lot of trouble. And in fact, I'd be willing to bet, now, once again, no one in this room, but I'm sure plenty of you have helped other people, who've had to deal with, hey, I put all my VMs in the default location, which was the system drive in a mouse space. Sure, no one's ever done that here. But storage migration is a great get-out-of-jail-free card for mistakes made in configuring storage. Today, with Server 2008 R2, if you run out of space, if you overload your storage and you're running out of I/O bandwidth, you're in a world of pain, and it is really hard to get at. Storage migration in Server 2012 just makes it really easy to fix up problems, go in there, and get the system running well again. So how does it work? First thing, and I do get asked this, so I do like to highlight it, the virtual machine always stays running where it is. Storage migration is not about moving the running virtual machine, it's about moving the storage of the virtual machine. So we have a running virtual machine, reading and writing to its virtual hard drive. A user comes in and says, hey, I want to move this to another location. And that other location, by the way, it can be an SMB share. It can be a USB drive. It can be a SAN. It can be DAS. It can be anything. Anywhere that we support storing virtual machines, you can do a storage migration to it. So we go, OK. And the first thing we do is we start mirroring all incoming writes. The moment you say, do the storage migration, we go, OK, create a file over there, and in your writes, send them over there. Once we've done that, we do a one-pass copy. We just go through and we copy the contents of the virtual hard drive while we're continuing to mirror the writes. Once that one-pass copy is completed, we're able to switch across to the destination, and then we delete the source. It's actually quite simple. So I am going to skip over this demo. It's a little bit of a long demo, and they have drinks after this. I'm sure you will want to get to that rather than do that. Storage migration is quite easy to do through the UI. You just use the move wizard that you've seen for the live migration. Only instead of saying move the virtual machine, you say move the virtual machine storage. We then provide you a lot of options where you can go through and click a bunch of things, and then it sits there, and you see the progress bar go for the first 50% and jump to the end. So rather than making you sit through that, let's jump over that. One thing I will highlight, I am cheating a bit here. This is a PowerShell example for move VM storage, where I'm saying, OK, let's move this VM to the K drive. We allow, with storage migration and also with live migration, we allow you to say, OK, move the virtual machine to this folder. We also allow you to go in and say, you know what? Move the VM configuration file there, and this VHD there, and that VHD there. And with storage migration, we also allow you to go, you know what? Leave the config file there, and leave that VHD there, but this VHD move over here. And can we move the save state file over here? Very flexible. I will say, if you want to do that in PowerShell, it is quite possibly the most complicated PowerShell command I've ever seen. I have a sample written up on my blog if you want to go and use it. But honestly, and we spent, we came up with half a dozen different designs to try and convey in correct PowerShell-ese, all these different options. And we were going back and forth with the PowerShell team, and we kept on coming out with problems. The solution that we ended up implementing is that you have to provide us a parameter, which is an array of hash tables. So it's quite impressive. And if you want to see it, go to my blog, look for PowerShell and storage migration. It is quite mind-bending. And I unfortunately, I had to write the help for those PowerShell commands, and I had to do all the examples. And so a very common question that I get about storage migration is, OK, what's the performance? And not just what's the performance impact? So let me talk about the performance. The performance of a storage migration is actually pretty darn close to doing an unbuffered file copy. And we worked hard on this because it would have been a bit embarrassing for us if we'd done all this work on storage migration and then we found out that users were going, you know what, it takes so long, I'm just going to shut it down. That's not what we wanted. So compared to an unbuffered file copy, we're usually within 10%. But here's the big caveat. No one does unbuffered file copies these days, so you probably don't know how long that takes. Windows Explorer, if you drag and drop a file, it always does a buffered file copy. And what happens when you do a buffered file copy is there's a whole lot of cache used, a whole lot of memory gets used. It is, one, not recommended for when you're copying really large files, which, hey, VHDs are really large files by definition. And two, on the Hyper-V team, we have this belief that people running Hyper-V might want to use the memory for virtual machines and not for copying big files around. So we do an unbuffered file copy. It is slower than if you just do a drag and drop in the shell. But if you want to get a feel for how long it takes, xcopy/j actually performs an unbuffered file copy, and it's very similar to storage migration. And I've actually had 2 or 3 times now with the beta and the TAP program, where I had someone contact me and basically say, like, man, storage migration on this system is taking forever. And I'm going, hey, can you shut down the VM and try and do an xcopy/j? And they're going, oh, okay, shut down, done an xcopy/j. And they're like, man, that's taking forever too. I'm like, yeah, your storage sucks. And please go get that. The other thing that people ask about is, what's the performance impact? And really, it's just a big file copy. But it's also a big file copy. It has the same performance impact that sitting down on the box and doing a big file copy would have. It causes I/O churn. It does have potential to affect the server performance. Now, if you're using storage migration in the way we designed it for, this isn't actually a big deal. Because the way we designed this for is you want to move a VM from this storage device to that storage device. And if you're doing that, what you'll realize is actually most of the I/O impact is on the storage device you're moving to. We don't generate any new write operations on the source device, and we're only doing a 1-pass copy on the source device. So we do generate some extra read. We generate a bunch of read and write on the destination device. However, if you're like a certain reporter, who shall remain nameless, who at a Windows Server launch event came up to me and said, hey, I've been trying the storage migration thing, and when I do it, the performance of my system, like the virtual machines is stuttering, and like everything's really bad. Like what's happening? I'm like, okay, can you show me? We haven't seen that. He had 4 virtual machines running on a single 5400 RPM laptop drive, and was trying to do a storage migration from one folder on that drive to another folder on that drive. And yes, it did not perform well. So please, a little common sense, and you won't have any problems with storage migration. So that said, we do have a single setting for storage migration, and that is the number of simultaneous storage migrations. Honestly, I don't really know why we have this. It's there to stop people doing too many storage migrations on their laptops. It is set to 2 by default. We support having it set up to 57,600. That's the ceiling. So if that's a problem for you, please let me know. But honestly, this is really just about, it's a safety net. You know, think about what sort of storage you have in place and set this to a reasonable value. In most of my deployments, I'm running a mix of SATA and SSD. I run RAID arrays. I usually set this to 10, and I've never had a big problem with that. So the final thing I'd like to talk about with virtual machine mobility is something that is near and dear to my heart and very painful for me to talk about. And you'll see why as we go through this. That is importing a virtual machine. So in Windows Server 2008 R2, possibly the hardest thing in the world to do was to have 2 Hyper-V servers and to just move a VM from A to B. Just shut it down and move it across. Honestly, sometimes it was easier to set up clustering and do a cluster than to do that. And there were 2 problems that we had. First problem, I'm going to ask for a show of hands. This is a story we heard a lot, and I want to know if it's happened to anyone here, is something would go wrong. There'd be a disk failure, there'd be corruption, there'd be elephants loose in the data center. Something goes wrong, and your system's gone, and all you have left is a disk with some XML files and some VHD files, and all you want is to get that connected to Hyper-V. Has anyone here been in that situation? Yep. It's not possible, is it? Can't do that. Yeah. In 2008 R2, we required that in order to import a virtual machine, you had to first export it. If you didn't export it and you just had the XML files and the VHD files, it didn't work. The second problem we had was, let's say, another show of hands, how many people here have tried to do the right thing where they went, okay, I want to move this virtual machine, so I'm going to export it from here, move it over there, and import it there? How many people have tried that? So got about a third of the room. So of you people, how many did the end result virtual machine look exactly like what you wanted? No hands. So the first thing is, I have to apologize because, seriously, that's my fault. It is my fault. It was my feature. Sorry. But import in 2008 R2, these days I kind of compare it to a zombie walking across down a street. It's a mental image. There's a zombie walking down a street. And as it's going, it's dropping body parts. That's what zombies do. Fingers, arms, ears, so on. But as it drops body parts, it keeps on moving. You know, it never stops. And importing a virtual machine in 2008 R2 is kind of like that. Because in 2008 R2, if you import a virtual machine, if there's any part of that virtual machine that we don't understand, we just throw it away. So the most classic one is you import a virtual machine, it's trying to connect to a virtual switch that isn't there. Okay, disconnected. Virtual hard drive not there. Okay, that's gone. Some more esoteric ones that I like. That VM is trying to use more virtual processors than we have in the system. Okay, 1. That VM is trying to use more memory than we have in the system. 512. Import in 2008 R2 will never fail. It will always say that it succeeded. And it will always give you a VM at the end of the day. That VM may look nothing like what you started with. So in 2012, we've done 2 big changes to kind of address our sins of the past here. The first one is we now let you take just the raw XML files and VHD files and import them. You don't need to export anymore. We have an export button in the UI. All it does is copy the files. And, even nicer, we allow you to take the raw files from 2008 R2. So the next person who comes to me and says, I've got a 2008 R2 server and it crashed and I've got a bunch of XML files, what do? I'm going to say, install server 2012. The second thing that we've done is we've built what we call a fix-up wizard. I'm going to show you a video of the fix-up wizard. And I'm showing it to you here in the context of import, but we actually use this all over the place now, in that we have the ability to allow you to choose what we do when there's an error. So here I'm going to select to import a virtual machine and provide some information. And this virtual machine has a couple of problems. The first one is going to be that it has too many virtual processors. Key thing that we did in this wizard is we always show you the old value. So here, let me see if I can use this mouse to pause on this page. So here's the network page. And this one was a really important one. This has actually shaped a lot of our thinking around the fix-up wizard process. Because for you people who had the bad experience with import, I'm sure some of you have had this experience. I know I've had this experience. You get the virtual machine. The network names didn't match. So the networks have been disconnected. And you're sitting there at the settings, looking at it and going, one of these network adapters went to the public network, and one of them went to the private network. And if I get them backwards, all hell's going to break loose. And I don't know which one is which. So this is one of the reasons why we made sure that whenever possible, we show you, hey, here's what we're looking for. So that if you're in that situation, you can go, oh, okay, this one was connected to public. So something that I haven't demonstrated today, frankly, whenever I've demonstrated it, this hurts me to demonstrate it, but it is kind of cool, is that, as I said, we have integrated this fix-up concept all over the place. You can actually now do a shared nothing live migration between two computers where your virtual network names don't match. Now, in the past, that would have just failed. Now, with Server 2012, if you try and do that, this page will come up, and we'll just say, hey, we can't find this network over there. Which network do you want us to use? And you can go ahead, do the migration, and that all works. So let me unpause this. So that's going to go ahead and complete. I'll do the import, and now I have that virtual machine, and it looks exactly like what I expect. Any changes that were made, I got to choose what change was made. Now, I would like to show you how to do this in PowerShell. This probably comes in as the second most complicated PowerShell commandlet that we have, the storage migration being the first one. So what happens in PowerShell? Here I've gone, OK, let's try and import this virtual machine. I've got a nice little error message. Something I've learned, by the way, because this is the first time we're doing a big investment in PowerShell, something I've personally learned. No one reads these error messages, which is kind of annoying, especially in this case. Because if you look closely at this error message, what the error message actually says was, we weren't able to do this. Can you please use this other command? And I've had a number of people contact me and say, I tried to do import and it didn't work. I'm like, use compare VM. So you try import, it didn't work. We say, hey, there's incompatibilities. We need you to use compare VM. So I go and I use compare VM with the same parameters. And this actually returns what we call a virtual machine compatibility report. Now, this is actually a really neat tool. You can use this outside of import. If you're doing planning, if you're looking at your environment, compare VM can take either an existing virtual machine on the system or an XML file, and you can actually take a virtual machine on one system and say, hey, can you compare this VM to that remote system? And we actually go through and do all our checks, and we'll come back to you and say, well, if you were to try and move the VM over here, here's the problems you're going to encounter. So it's actually a very handy tool. So you say compare VM, and it reports that there are two incompatibilities. So I can look at the incompatibilities. I get the detailed text that we got in the UI saying, hey, Ethernet virtual processors. The compatibility report actually has a virtual machine object on it. So what I can do is I can go in and I can fix up. You can see here, set VM processor on the VM on my compatibility report. Set it to 2. In this case, I'm disconnecting the network adapter. Once I've gone through and fixed up that virtual machine object, I just say import VM, that compatibility report. And it goes ahead and does the import for me. So the final thing that I'd like to talk about is comparing technologies. And we have a whole slew of new features and functionality coming in this release. And something that I hear from a lot of people is they get confused about, like, well, wait, if you do live migration without clusters, why do I need clustering? If you do Hyper-V replica, why do I need backup? And all sorts of questions like this. And in my books, the best way to answer this is with a big table of smiley and frowny faces. So this is kind of my summary. I always get asked, what are the straight faces for? And I say the straight faces are for where you have partial coverage. For instance, clustering, 0 downtime. Well, you can do live migration inside a cluster, and that is 0 downtime. But if a node goes down in a cluster, you do have downtime until we start the VM up. But I find this table very useful. What I believe is that different people are going to choose different sets of these technologies according to their needs. And I have no doubt that we're going to have users who end up going, you know what? I need that all. When I look at this table, I need everything in there. We're going to do all of this. And it's something that we've done a lot of work to make sure that all of these technologies do work together. But I'm also sure there are going to be plenty of people who, when they look at it, go, you know what? I don't really need protection against site down. I'm not going to use replica. Or, I don't really need, instant failover if there's a server down, so I'm not going to use clustering. There are trade-offs in all of this. So finally, I have a useless slide because I'm mandated to have this. Last session of the day, related content, you've already missed it, sorry. But if you had a time machine, these would be good sessions to go to. Please do feel free to shoot me questions on Twitter. I also have my blog there. There's a little feedback form. You can feel free to ask me questions through there. I would like to thank everyone for staying until this late point in time. I'm going to open for questions. But first, I ran out of cool prizes. The marketing team isn't giving me any prizes, but I did get given a bottle of wine as a speaker gift. This is actually Alan's one. He was kind enough to bring it along. So I'm going to give away this bottle of wine. I should probably say I'm not allowed to give this to governmental officials. It's under $50. It might be okay. I don't know. So the question that I was trying to debate, bottle of wine, what question would I ask? The question that I ended up thinking was, okay, so I want to go for who has the most number of clusters, of Hyper-V clusters in their environment. So let's start. How many people, one Hyper-V cluster in their environment? 2, 3, 4, 5. Let's go. How many do you have? 4. How many? 6 or 7? You guys have to arm wrestle. These numbers aren't accurate. He's giving up. So the bottle of wine is yours. Feel free to come up and grab it. While that's happening, I'm open for questions. It is also 2:56, so the drinks are open. I'm fine if people leave to go to that, but thank you all.